Hello, everybody, and welcome to the Rutgers Geology Museum Geologic Time Late Night. We're about to start, and we welcome you back. This is our second late night of the semester. And as now usual, today we will have a Geologic Time trivia. So if you can go to your Menti, www.menti.com, you're going to use the code 6680711 to log in. And when you answer your questions, we will be able to see your responses. In addition, you can use the QR code here. You can scan it from your cell phone. That will take you directly to the same web page. Okay. And I'm giving you a couple of minutes to just do that and find it. And shortly, Ria Sarkar, our geologist in the house tonight, and me will guide you through the questions and answers. Okay, if we are ready. Ria, are you here?
Yes, I'm here. Can you hear me?
Yes, I can hear you, and I can see you. Yes. All right. So remember that this is going to be questions that each question is a point. Please keep your tallies for the questions that you got right and wrong. And then at the end, you will see in what category you are as a geologist. Okay. Are we ready? Yes. Okay. So here we go. Trivia question number 1. Which of the following are the longest subdivisions in the geologic time scale? A, epochs, B, periods, C, eras, D, eons.
The answers for all of them. We'll give some more time.
All right, yeah. And if you had any trouble with the Menti, you can also write to us in the chat and we will see your answers.
Okay, so I think we have an answer here. So you guys all chose eons.
And that is correct. The longest subdivision of the geologic time scale are eons. All right. Next question. Question number 2. How old is the Earth? A, 13 billion years old, B, 65 million years old, C, 4.6 billion years old, or D, 4.6 million years old. Let's see. Ria is going to check.
You're putting in the right answer. I think we already have 3 more people here, it seems like. And I think that's all the answers. Yep. Okay, so everyone chose C, 4.6 billion years old.
Let's see what the right answer is. And you were right, guys. Good job. The Earth is 6.6 billion years old. Let's go on question number 3. How did scientists determine the age of the Earth? A, measurement of sediment depths. B, relative dating of fossils. C, radiometric dating, or D, analysis of climate records. Think about what geologists do when they go out in the field and they collect their samples, then they analyze their samples in the lab. What do you think they do? Do we have an answer?
So we have, okay, so now we have most of the answers for B, relative dating of fossils.
Okay, let's see. So actually, scientists determine the age of Earth by radiometric dating. which means that they are comparing the amount of radioactive and non-radioactive isotopes, right? Atoms that forms that rock to determine the age. Have you done anything like that, Ria?
Yeah, I was just about to say that I was actually just tutoring about this today earlier. And so I just want to point out the relative dating. It's just, the age of the rock in comparison to other rocks. So you're not putting an exact number on it, right? So I would say like, oh, this rock is older than the other one, or the one on the bottom is older and the one on top is younger. So that's relative age. And radiometric is what, Patty, you just mentioned about measuring the isotope. So you get an exact number from that. So you can say this is 1 billion years old. So that's where you get the age from.
Great. We're going to move on to question number 4. How long ago do scientists think the first life evolved in Earth oceans? A, 3.5 billion years ago. B, 2.2 billion years ago. C, 5 million years ago. Or D, 252 million years ago.
A lot of people putting in the right answer. We'll just wait for a few more answers to come.
I can wait. I'm excited to hear what you say.
And it looks like everyone has chosen A, 3.5 billion years ago.
Let's see. And your guys are right. That is correct. We have A, 3.5 billion years ago for how long scientists think first life evolved in Earth oceans. We're going to go on question number 5. Oxygen started to build up in the atmosphere for the first time approximately 2.3 billion years ago. What caused this to occur? A, plant photosynthesis. B, volcanic emissions. C, weathering of rocks. And D, cyanobacteria photosynthesis. Let's see how good you are on biology.
I think this group is pretty good with biology because I see there's a lot of votes for one answer here. And I think they're all in. So most of you have chosen D, cyanobacteria photosynthesis.
And that is correct. Cyanobacteria are bacteria that could actually carry out the process of photosynthesis. And they were early organisms in Earth that were responsible for oxygen in the atmosphere approximately 2.3 billion years ago. And you can see the picture right here. All right, we're going to use this time to remind you that if you just joined us and you were a little late, you can go to www.menti.com and use the code 6680-711 to go into our page where we're recording your responses to the trivia questions that we're asking tonight. If you have a smartphone, you can scan this QR code here, and then we will be able to see your responses. If you have trouble, you can always tell us in the chat, okay? Okay, so we're going to go. Now we're going to go on question number 6. Which one of these fossil deposits is the first to preserve soft-bodied organisms? A, Mason Creek. B, Burgess Shale. C, Hell Creek Formation. D, Solnhofen Limestone. And I will admit that I learned this studying for this trivia night.
I think most of you already know the answer. I'm just going to wait for a few more people to get their answers in. Okay, and it looks like most of people have chosen B, Burgess Shale.
And here we have it. Yes, correct. It's B, Burgess Shale. And let's go on question number 7. During which time period did the trilobites live? A, Paleozoic era, B, Mesozoic era, C, Cenozoic era, or D, Precambrian.
Group is putting in the correct answer, I see. So go ahead and keep.
Can you repeat the last thing you said, Ria?
I was saying it seems like so it seems like now people have chosen A for Paleozoic era.
All right. And that is correct. A, Paleozoic era is the time period where the trilobites live. And when we're back open, you should come to the museum and see our collection of trilobites. All right. Then number 8, which of these animals has the longest evolutionary history? A, dinosaurs, B, sharks, C, horseshoe crabs, or D, spiders?
Oh, yeah, keep putting in your answers, guys. It's okay if you're not sure, you can take an educated guess. So put something down. I'm gonna wait another minute because I think they're still waiting on some more answers. Okay, so it looks like most of everyone has chosen B for sharks.
Okay. But it's actually C, horseshoe crabs. And there's a question on what is evolutionary history. So longest in time, right? Which of these animals have been on Earth for longer time? And horseshoe crabs are the ones of the 4 that you had as an option for this question. So if you go to the beach and you see horseshoe crabs, you're looking at the animal with the longest evolutionary history. They have seen the Earth change for a long time. You're welcome, Rachel.
And stay tuned if you want to hear more about horseshoe crabs, because hint, hint, I will talk about it later.
Great. Number 9. Between which 2 time periods did the first of the big 5 mass extinctions occur? A, Ordovician and Silurian, B, Permian and Triassic, D, Devonian and Carboniferous, or D, Cretaceous and Paleogene? Let's see. What are people saying?
So the 2 most popular answers here. So the first one is the Cretaceous and Paleogene, and then the second most popular is the Permian and Triassic.
Okay, let's see. And the correct answer was A, Ordovician and Silurian. And you can see here in red where is at the end of Ordovician. All right. So number 10, which of these types of animals was the first to leave the water and inhabit the land? A, frogs, B, spiders, C, crabs, or D, millipedes?
So we still have some more answers coming in. And it looks like most people have chosen C for crabs.
All right. But the right answer is millipedes. They are believed to be the first animal to leave the water and inhabit the land. All right. And again, if you just joined us and you just came in, we are at the Geologic time trivia, and you can post your responses at the www.menti.com using the code 6680711, or you can scan the QR code here, and that will take you to the page where we're collecting your responses. And we will continue momentarily with the rest of the questions. And remember to keep track of your score, okay? You can let us know how you're doing in the chat. Question 11. Which of these adaptations allow vertebrate animals to colonize the land? A, amniotic eggs. B, lungs instead of gills. C, feet instead of fins. D, all of these.
So most of the answers were for D, all of these.
Okay. And actually, you were correct. All of these. And you can see here picture of the lobe fin fins for the early amphibians. You can see here the embryo. And all of these adaptations allow life on land possible. Question number 12. Which of these was the largest mass extinction event in Earth history? A, Permian mass extinction. B, Triassic-Jurassic mass extinction. C, Devonian mass extinction. D, End Cretaceous mass extinction.
So we actually have the same amount of answers for A, Permian mass extinction, and for D, the End Cretaceous mass extinction. Oh, no, it's End Cretaceous has the most.
All right. Well, the answer was A, Permian mass extinction. You can see here in the red square.
Yeah, so that one, about 3/4 of all life and about 95% of life in the ocean disappeared.
Now, question number 13. The Mesozoic era is also known as the age of the A, mammals, B, fish, C, reptiles, D, primates.
It looks like most of the answers are in, and it is for C, reptiles.
And that is correct. The Mesozoic era is also known as the age of the reptiles. All right. So question number 14, what is the name of the supercontinent that started to break up during the Triassic period? A, Gondwana, B, Pangaea, C, Laurentia, or D, Rodinia?
Everyone is going to get this one right. Okay, so literally everybody who is playing has chosen the right answer, or they've chosen an answer, which is B.
Pangea, yes. The name of the supercontinent that started to break up during the Triassic period is Pangea, and you can see it here. You can see the breakouts through.
And a super fun fact, New Jersey actually used to be neighbors with Morocco, so our coastlines were connected.
All right. Question number 15. Which of these animals lived during the Mesozoic era? A, dinosaurs, B, humans, C, trilobites, D, woolly mammoths.
So most of the answers I got were for A, dinosaurs.
All right. And that is correct. The answer is dinosaurs. You can see them here. Okay, and this is I think the last announcement, but if you just came in and joined us, please go to www.menti.com, use the code 6680-711, and you can see the questions and answers so we can record your answers. And you can scan the QR code if you have a smartphone, and that will take you to that webpage. And if you have been playing, remember to keep track of your score so you can let us know shortly what were your counts. All right, so question number 16. The Cenozoic era is also known as the age of the A, birds, B, fish, C, mammals, D, reptiles.
So it looks like actually we're gonna wait for some more answers to come in since it's an even split. And okay, so I have for C, mammals.
All right, Cenozoic era is the age of the mammals. Yes, that is correct. Question 17. During which geologic period did flowering plants, angiosperms, became common? A, Devonian, B, Permian, C, Triassic, or D, Cretaceous?
So far, I see an even split across all of these answers. So we're gonna wait another minute.
Okay.
Okay, so it looks like most. Oh, okay. Then we're even. So the top two answers are the Devonian and the Permian.
All right. It's actually D, the Cretaceous. That's when flowering plants became common. Question 18. About how long have modern humans lived? A, 200,000 years, B, 6 million years, C, 50,000 years, and D, 1.5 million years.
So it looks like most of you have chosen the choice C for 50,000 years.
Okay, and actually is A, 200,000 years. Okay. Question number 19. About how long ago did the last glacial period end? A, 5,000 years, B, 20,000 years, C, 40,000 years, and D, 100,000 years.
So it looks like most of the answers are here for C, 40,000 years.
Okay. The answer is actually B, 20,000 years.
So at that time, most of northern New Jersey was covered in a thick ice sheet. And if you're familiar with central Jersey area, the end of the glacier was around Woodbridge Mall.
Yeah, and again, if you go to our museum, you will see some specimens from that time as well. Question number 20th. In which epoch did we live today? A, Miocene, B, Oligocene, C, Holocene, or D, Pliocene? Pliocene, sorry.
Just getting some final answers in right now. And it looks like it's a tie between the Oligocene and Holocene.
All right, let's see. Oh, it's Holocene. The epoch that we live today is Holocene. Okay. And so that is the 20 questions that we had for you tonight. So at this point, we want to hear how do you do. So if you got from 0 to 10 questions right, you're a budding chronologist. If you have 11 to 15 points, you're an Earth history enthusiast. And if you got 16 to 20 questions right, you're an Earth historian. Can you put in the chat what category are you? And we thank you for playing with us tonight. We hope you have fun and you enjoy this part of the late night. We have 2 more parts. So I am going to show you this slide that has what is next. So next we have a time scale activity and you're going to need some supplies. So if you don't have them with you yet, just go around and try to get whatever you can get around your kitchen, your play area, your craft supplies, and Ria will be with you shortly to do this activity, okay?
Can everyone hear me right now?
I can.
Okay. So yeah, go ahead and grab any item that you have of the same size, like Patty just said. So I can show you guys, and if you go to that scan that QR code, then you can go to the Padlet. Could you share that again?
Yeah.
Maybe give people some more time. So I can show you guys what I made. Maybe it's easier to put on my document camera, but here's a close-up. So I used some dinosaur stickers here, and I'll show it to you with the other camera I have. a little hard to see this. Okay, so essentially what I've done is I started over here. I'm gonna move it this way, get the whole picture. So I started with the beginning here. Here's the Precambrian period. And we're coming up here, and it's pretty long, so I have 20 of my dinosaurs. And this is still the Precambrian, and then I come down to, let's see if I can move it up right here, okay. So then I have the next one is the Paleozoic Era, so I have these 4 dinosaurs representing that. And then the next one I have is the Mesozoic over here. So I have just 3 of these dinosaurs representing the Mesozoic. And then I have this guy over here representing the Cenozoic, which is 65 million years ago. And this little itty bitty end of a tail is human existence. So that's 2 million years ago. So I'm going to show you another way to do this. I have some shells here. So I'm just going to put them in one line. And I'm just going to put these shells here. So I have 20 shells. They're probably not all going to fit on the screen, but I'm going to try my best. And so when we're thinking about the geologic time scale, like you guys learned that the Earth is 4.6 billion years old. And the universe is 13.8 billion years old. So when we think about human existence, humans have barely scratched the surface. Okay, so that's, you know, if I think about hundreds of years ago or thousands of years ago, that feels like yesterday compared to billions of years. So after I share my time scale, Patty, you can share yours as well. So you can see some different ways, and then maybe we can share what others have created. So when you take pictures of your creations, and please post them to the Padlet, so then we can all see what you're doing. So Patty, I think I don't have running out of space here, so maybe you can show your
Yes. So if you are into the holiday seasons like I am, there's a lot coming on, right? We just passed Halloween, we had Thanksgiving, then there's the holiday season that has many different things that you can do. So in my case, I went with this little tree, and I created a couple of samples for you. So the first thing, and I actually have setups that to see if you have them at home. Have you ever used the rainbow loom? If you ever use the rainbow loom, you can actually use these kind of tools where you can put your little looms here, and then you can actually make it into a bracelet. So if you look at my bracelet, I have it here with the different colors, and I can actually wear it. We also have, if you are having trouble finding anything where to put your beads at home, this one actually was made with foil. So I just put the foil around into a long string, and then I created all these put all the little beads together. Be careful with this one if you're doing foil, because if you don't leave enough space in between the beads to turn it around and twist it around to represent the geologic scale, then it may break. So, but it is another way. And this one you can actually put, I don't know, somewhere to decorate your car or to decorate in your room. This one was super easy to make. It was really good with a pipe cleaner as well. It worked. And so you can then, once you have it, you can turn it into like a keychain. And if you're outside and you go and show it to people, you can actually tell people the history of planet Earth, right? You will carry it with you and you can talk to others about it. So these are the 3 models that I have. I have the foil, I had the pipe cleaner, and we have the rainbow looms in the form of a bracelet. And we can't wait to see what actually you are creating. What is your creativity is going to dictate for tonight's craft. Ria, are you there?
Yes, I'm here.
Okay.
So I just wanted to also mention, so if we all can think, so thinking on the geological time scale, so here's some fun way to think about it. So say if we overlay a 24-hour clock on the history of the Earth, right, all of the major events, so this is one way we can think, right? So let's say the Hadean period starts at 12 a.m. and then it ends at 4:10 a.m. And so this is when unicellular life appears, and it appears right before 4 a.m. The next period we have is the Archean, and that begins at 4:10 a.m. And that's when photosynthesis will begin around 5:30 a.m. And so the Archean ends at 10:57 a.m. So then we have the Proterozoic, right? And so it goes on until 9:10 p.m., right? So that's a really long time, from 10:57 a.m. to 9:10 p.m. So the first multicellular life will show up around 5:30 p.m. The Cambrian will start at 9:10 p.m. And the Cambrian explosion, right, when all of the life, right, all of that diversity happens around 9 p.m. That ends at 9:27. The Ordovician starts at 9:27 p.m. So we see mollusks and arthropods are dominating the seas, and that will end around 9:41 p.m. So we're still way old, right, in the old times. So we get to Silurian, who starts at 9:41 p.m. and it ends at 9:49 p.m. That's when you have the first land plants. The Devonian will then start at 9:49 p.m. and that's the age of the bony fishes, and that ends at 10:07 p.m. So the Carboniferous is next, and that's when that's the coal age. We have swamps, we have amphibians and insects that are invading the land, and that's at 10:07 p.m. and that ends at 10:26 p.m. Now we get to the Permian, which is at 10:26 p.m. and that's when the reptiles are starting to arise, right? And that one ends at 10:41 p.m. Now we're getting to the Triassic, which is 10:41 p.m. and the dinosaurs are here, right? And that one ends at 10:57 p.m. The dinosaurs this is part of the Mesozoic Era, right? So the Triassic, Jurassic, and Cretaceous. So the Cretaceous will end at 11:39 p.m. That's when the dinosaurs go extinct. Then we get into the Paleocene, which starts at 11:39 p.m. When early mammals are appearing, and that ends at 11:42 p.m. Notice we still haven't gotten to humans yet, right? So the next one is the Eocene, which starts at 11:42 p.m., ends at 11:49. The next is Oligocene. That's, kind of our continents are starting to move into our current positions today. That ends at 11:52 p.m. The Miocene starts at 11:52. That's when hominids appear. That ends at 11:58. The Pliocene is starting at 11:58 p.m. and it ends at 11:59. And then the Pleistocene, which is when we have major ice ages, begins at 11:59 p.m. and ends at 12 a.m. So where are the people? The Holocene starts at 12 a.m. and ends at 12 a.m. So humans have barely even been here as compared to other prehistoric animals. Yes, Julie, I think we can share the Padlet. I don't have the... Okay, thanks. So let's take a look at what you guys have here. Okay, so we have a Lego timescale. That's really cool. I like this one. Here's a Pokemon that is fitting with the theme. Here's the Pokemon one. Here's another Pokemon Geologic timescale with stamps. That's really nice. And then here we can take a look at some of these animals by the time period that I just went through. We can take a look at what they look like. So here is the Proterozoic Eon, right? So we see this type of ancient jellyfish, right? See these really cool looking creatures here, plants. There's the early Paleozoic. We have the Cambrian and the Ordovician. Notice how we have the Trilobites here, right? The oceans look very different than today. Maybe I can make this a European. There we go. And that one's not working as well, so let me go back. Okay, and then here we have the late Mesozoic, which includes the Silurian, Carboniferous, and Permian. So we can see those trees, right? Kind of like a swamp. You see some reptiles, right? Here's the early Mesozoic. We have the Triassic Period. We start seeing our dinosaurs here. The late Mesozoic, Jurassic, and Cretaceous, right? We see Mosasaur, we see pterosaurs, ammonites, ankylosaur, right? Everyone's favorites are up here. And here's the early Cenozoic, right? The Paleocene, Eocene, Oligocene, and Miocene. We start seeing these mammals. There's the late Cenozoic, so we see Pliocene, the Pleistocene, and Holocene, right? And so snakes, right? We see the woolly mammoths and horses and cows and pretty seashells. So you guys could just take pictures of your timescales and just upload them onto the Padlet. So you can scan the QR code here and you can upload your creation. And we'd love to see that. Patty, did you want to show another one that you're making?
Comment. So we have, I have my beads bag, and my daughter actually was trying to put together like a shorter version of one. And if all the models that I usually see at the museum, usually it's represented into like a cylinder. So this is me trying to practice with the foil. So if you're at home and you want to do that, you just have, you see how it breaks easily, but you just need to fold it, and you can use like skewers, wooden stick to help you, and that's basically what this one came on. And another thing that we were discussing as we were practicing with this was how, like, if you represent it with your body, as you can see here, the Holocene is a lot thinner than the rest of it. So if you were to represent the time scale around your body, imagine that your fingernails are the Holocene, and this is our existence compared to how long the planet is. This is very short compared to everything else. Basically, if your body represents the whole geologic time scale, and you use a nail filer and you just file your nails, then you just wipe our existence from the Earth history, right? So this is for you to have an idea or impression of how little we've been here compared to everything else that we know about planet Earth in geologic time.
And so I can share that clock that I was actually just telling you guys about. So I can share the image of that to give you a better sense. So like I mentioned, so here's the 24-hour clock, right? And so we can see the Hadean, right? And then the Archean is pretty long, the Proterozoic, right? Then you get to the Paleozoic, the Mesozoic, the Cenozoic is over here. And you can see the first hominids, right? That's 2 million years ago. And I don't even think they put the Holocene. They didn't even put the modern people on here. So we're right at the end, barely even here. But you can sort of see this, it's pretty cool to look at.
Do we have any images in the Padlet?
I don't see any new ones. Maybe Julie would know, I think.
No, I don't see any new ones. We'll go ahead and get set up for the next part, which is the Pokemon paleontology part.
And once you're done tonight, you don't have to do it right now, but once you're done with your model, post it. We want to see it, okay?
And don't forget to tag us.
Okay, so I am going to start sharing. Let's see. Okay. Present. Okay. 6:48. Okay, I guess we can start 2 minutes ahead of schedule. So today we're going to talk a little bit about Pokemon and their paleontology. And so my name is Julie Criscione, and I am the program coordinator at the Rutgers Geology Museum. And helping me talk about Pokemon today is going to be Ria Sarkar, who is our tour guide, who has been talking all night to you guys. So without further ado, let's get started. So for those of you who are not too familiar with Pokemon, Pokemon is a Japanese series that was originally created by a guy named Satoshi Tajiri, and he was inspired by his childhood hobby of collecting insects. And so I think Pokemon first came out in the late 1990s, and actually right now it's the highest grossing media franchise of all time. And so if you're not too familiar with the series, when in the Pokemon universe, when a kid reaches a certain age, they can leave home and go on a journey to become a Pokemon trainer. And on that journey, they travel the world and they catch Pokemon and they collect them, and then they can train them and battle them with each other for fun. So when Pokemon first came out, when I was probably in 2nd or 3rd grade, there were 151 Pokemon. And since then, it's been probably almost 25 years by now. And there's actually almost 900 of them. So that seems like a ton, and it is. But compared to how many animals there are in real life, it's not quite so many. But anyway, so 900 Pokemon is a lot. And some of those actually are fossil Pokemon based on prehistoric creatures. And those are the ones we're going to be talking about today. So before we get started, there's 2 quick things I wanted to mention for people who aren't too familiar. The first thing is, what is a Pokédex? So I actually have my childhood Pokédex right here. And the Pokédex is basically a portable Pokemon encyclopedia. So a Pokemon trainer who goes out on their journey to collect Pokemon, they'll get a Pokédex. And whenever they encounter a new Pokemon, they can open their Pokédex and get more information about that Pokemon. So today, when we talk about the fossil Pokemon, we're going to be looking at some of the Pokédex entries about those different Pokemon. Now, the second thing I have to mention quickly is about evolution. So there's a thing called evolution in Pokemon, but it's not the same thing as biologists call evolution. So in Pokemon, evolution is kind of treated like a power-up or an upgrade. And so when a Pokemon battles, it'll gain experience, and eventually it'll level up. And when each Pokemon reaches a certain level, they can evolve into their next form. So obviously, this is not how it happens in nature. In nature, evolution is the idea of populations of animals having their characteristics change over very long periods of time. And this happens through a process called natural selection. And that is the process where beneficial traits that help the animal to survive are often passed down to their offspring. And if they're still beneficial, those traits are again often passed down. So over very, very, very long periods of time, animals can become better adapted to their environment. And once enough change has occurred, new species can evolve. So they're used different ways in nature and Pokemon. So I wanted to make that clear at the beginning. Now, the last thing I wanted to talk about really quick before we start with Pokemon is that because this is the geologic time late night, we're going to put all the Pokemon, the fossil Pokemon, into the framework of the geologic timescale. So as we learned in the trivia, the Earth is about 4.6 billion years old, and it was only very recently that animals evolved. So we think animals first evolved around 800 million years ago, but they didn't become abundant until about 540 million years ago. And so that little section of the timescale that is blue at the end, that is the time when animals were abundant. So all of the Pokemon that we're going to be talking about are going to be put in the framework of this timescale and when their real life counterparts would have existed. So without further ado, we can start talking about our first Pokemon. And that is, well, the first two are Anorith and Armaldo. And these two Pokemon are based on the real life animal called the Anomalocaris. And it existed back in the Cambrian period, so about 520 million years ago. So if we read the Pokédex entry on this guy, for Anorith, which is the smaller green one, it says that it's an aquatic Pokemon that lived in warm seas, and that it used its wing-like appendages to swim through the water, and its claw-like mouth appendages to capture prey.
Okay, thank you, Julie, for the introduction and for the first Pokemon entry. So Anomalocaris, so in real life, right? So Anomalocaris evolved during the Cambrian period, so around 515 million years ago, and it went extinct about 488 million years ago. And they're thought to have been closely related to arthropods like spiders, crustaceans, and insects. And there are 6 known species and hundreds of fossil specimens. The name actually has Greek and Latin roots, and it actually means unlike other shrimp or abnormal shrimp. I agree, it really looks super weird. And every species lived in a different environment, but they primarily inhabited the warm shallow seas, which is similar to Anorith and Armaldo. It also swam with its wing-like appendages and hunted with its claw-like appendages, which is also the same as how this Pokemon hunts.
Okay, so now we're going to move on to our next set of Pokemon. These are Kabuto and Kabutops, and they are some of the originals from when I was a kid, and they're actually my favorite. So in the original Game Boy Color video game, you could find a fossil of the Kabuto, and you would bring it to the science lab, and then the scientists would resurrect the Kabuto Pokemon from that fossil. So if we read the Pokédex entry for Kabuto, it says that Kabuto inhabited beaches 300 million years ago and has not changed much since. Once they are flipped over, they cannot right themselves. And to me, that sounds like a horseshoe crab. So I think these two were based on some sort of mix between horseshoe crabs and trilobites.
I definitely agree with that, Julie. So horseshoe crabs evolved 445 million years ago during the Ordovician period. And there are 4 species that are actually still living today in shallow coastal waters. So going back to your trivia question, when we asked about the longest evolutionary history, is the horseshoe crab. It's still living today. And they actually have a hard time, like you mentioned, Julie, to flip over like Kabuto. But the real life animal can sometimes use its tail, so I think it has a little bit of an advantage there. And trilobites lived around 470 million years ago during the Middle Ordovician period. They are one of the most diverse groups of extinct animals to be preserved, with an impressive 20,000 known species. They primarily lived in shallow water, and they were closely related to horseshoe crabs. And they went extinct at the end of the Permian period, about 251 million years ago, during that Permian mass extinction.
Okay, so moving on to our next set of Pokemon, we're jumping ahead a little bit in time to the Ordovician, so we're at about 485 million years ago now. And we have two Pokemon called Lileep and Cradily, and they are based on the real-life animal called the crinoid. And if we read their Pokédex entry for Lileep, which is the smaller purple one, it says that this ancient Pokemon attaches itself to a rock on the seafloor and catches approaching prey using tentacles shaped like flower petals.
So crinoids lived around 485 million years ago during the Ordovician period in saltwater habitats such as the deep ocean and coral reefs. There are around 600 species of crinoids today, although they were much more diverse in the past. And so crinoids, actually the ones with a stalk, are commonly known as sea lilies, and they do attach to the sea bottom, much like this Pokemon. However, not all crinoids have stalks, so there's also a group of unstalked crinoids that are free swimming, and they're called feather stars, which I think are really cool. And their arms were actually used for feeding, which is the same way that this Pokemon uses the tentacles to catch prey.
Okay, moving on to our next Pokemon. We're jumping ahead a little bit in time to the Devonian period, which is about 400 million years ago. And we have another two of the original Pokemon from my childhood. And these two are Omanyte and Omastar. Omastar is the larger evolved form with the spikes. And so if we read the Pokédex entry for these two, they say for Omanyte, which is the smaller one, it says that this Pokemon uses air stored in its shell to sink and rise in water, and that it swims in the sea by adeptly twisting its 10 tentacles. And then for the evolved form, Omastar, it says that its shell was too big for it to move freely, so it became extinct.
So ammonites evolved in the Devonian period, right? And so about 400 million years ago. They are the extinct relatives of modern-day cuttlefish, nautiloids, and squid. They are also one of the most common fossils found around the world today. They ranged in size from a few centimeters to like 3 feet in diameter, and they primarily lived in the shallow waters. And they were also highly diverse with around 10,000 species. And some common predators included larger fish, other ammonites, and mosasaurs. And so in Pokemon, the turtle Pokemon, actually Tirtoga, preyed on Omanyte and Omastar. And so the ammonites, actually, they went extinct at the same time as the dinosaurs at the end of the Cretaceous period. So it is believed, actually, that ocean acidification dissolved the shells of these young ammonites, which were sea surface dwellers. So ocean acidification is caused by high levels of carbon dioxide in the water. And so, although it is still unclear exactly how they swam, scientists do agree that they probably combined jet propulsion and the buoyancy of their shells, like in the Pokemon, to float around.
All right, so now we are still in the Devonian period, 400 million years ago, and we have a really cool fish Pokemon named Relicanth that was based on the coelacanth fish. And now if we read Relicanth's Pokédex entry, it says that this Pokemon was discovered during deep sea exploration. Its appearance hasn't changed in 100 million years, so it's called a living fossil.
So coming back to real life, coelacanths evolved approximately 400 million years ago, as Julie just mentioned, during the Devonian period. And they were actually thought to have gone extinct around the same time as the dinosaurs, about 66 million years ago. However, something very interesting happened. In 1938, a museum curator, Marjorie Courtenay-Latimer, she discovered a coelacanth off the coast of South Africa. So, it's not extinct. And so there used to be over 90 unique species of coelacanths, but only 2 remain today. They live in temperate waters of the ocean's twilight zone, which is about 500 to 800 feet deep. And so in the case of the Pokemon Relicanth, they say the appearance hasn't changed much in 100 million years, But for the coelacanth, it hasn't changed much in 400 million years.
Okay, so now we are jumping into the late Triassic period. So now we're in the Mesozoic Era, which is the age of the reptiles, like we learned from the trivia. And we're at about 225 million years ago. And we have a Pokemon named Aerodactyl, which is very closely based on pterodactyls or pterosaurs, which are extinct flying reptiles. And this is another one of the originals from my childhood. And in the Game Boy Color game, you would find a piece of old amber and bring the amber to the scientist in the lab, and then the scientist would resurrect Aerodactyl for you. So that never quite made sense to me. But in any case, so if we read the Pokédex entry for Aerodactyl, it says that a Pokemon was resurrected from the genes of an ancient dinosaur.
Okay, so as Julie mentioned, pterosaurs were flying reptiles that lived from the Triassic 228 million years ago to the Cretaceous period, 66 million years ago. Contrary to the popular belief, and as mentioned in the Pokédex, they were not dinosaurs, and I'm really sorry to break your hearts today if you thought that pterodactyls were dinosaurs. They're not. They lived during the same time as the dinosaurs. They were distant relatives, but they were not considered to be dinosaurs. They lived primarily near the seas, so close to their food. They lived in trees and in caves. And there actually is a real group, as Julie was kind of alluding to, of pterosaurs named after this Pokemon called Aerodactylus. And these here we have some of the images of the actual specimen on the screen here. But unlike the origins of this Pokemon, DNA actually cannot survive in amber for millions of years, even in the best conditions for fossilization. Though it's not useful for preserving DNA, amber is still important. It's an important preservation mechanism for smaller things like bugs, plant material, and feathers. But it's not likely to preserve parts of a pterosaur, even though that would be pretty cool.
Okay, so let's see. Moving right along. Now we're in the middle part of the Mesozoic Era, in the Jurassic period, which is about 150 million years ago. And we have two Pokemon called Archen and the evolved form Archaeops. And they are based on the extinct bird-like creature called Archaeopteryx, which I'm sure many people have heard of. And so if we read the Pokédex for these two, it says that Archen is the ancestor of all bird Pokemon. Archen itself could not actually fly, but moved by hopping from treetop to treetop. And then for the evolved form, which is the larger one here, it says that from the ground, Archaeops uses a running start to take flight.
So in real life, Archaeopteryx is believed to have been the first bird and is accepted as the last link between the dinosaurs and modern day birds. So if you didn't know, birds today are descendants of dinosaurs. So it lived during the Jurassic period about 150 million years ago in modern day southern Germany and Portugal. And so at that time, much of Europe was an archipelago of islands surrounded by a warm tropical sea, which sounds like a pretty good deal to me. I would totally love to live there. But unlike the Pokemon, scientists believe that Archaeopteryx would actually fly in short bursts like a pheasant. And there are also two competing views for how flight actually began, either top down or bottom up. So the top down theory says that they glided from rock cliffs or treetops, and bottom up theory suggests that they flapped up into the trees from the ground while chasing prey like bugs. Now, the anatomy of Archaeopteryx does have evidence for both of these theories, so this idea is still debated in the scientific community today.
All right, so now we're on to everybody's favorite. We're in the Cretaceous period, which was between 145 and about 66 million years ago. And so now we have dinosaurs. So it actually surprisingly took the Pokemon Company about 10 years to release their first Pokemon dinosaur. So they started off with the bottom two, which were based loosely on the Triceratops and also on the right, the Pachycephalosaurus. But the two that we're going to focus on today are at the top, the one based on the theropod dinosaurs like T-Rex, and then the other based on sauropods. So if we start in the early Cretaceous, we have two Pokemon based on sauropod dinosaurs, and their names are Amora and Aurorus is the evolved form. And so they lived about 120 million years ago. And if we read the Pokédex entry for Aurorus, which is the evolved one, it says, an Aurorus was found frozen solid within a glacier, just as it appeared long ago.
So going back to your point about Pokemon taking 10 years, that's interesting. I would have thought they would have done it sooner, right? But anyway, in real life, Amargasaurus was an herbivorous sauropod that lived during the early Cretaceous period around 132 million years ago. They are closely related to other species of long-necked dinosaurs like Brachiosaurus and Diplodocus. However, this dinosaur is different and unique because it actually had a shorter neck, and you can also see it has very prominent spines going from the neck down to the tail. So contrary to the Pokédex, though, Amargasaurus lived, like I said, during the Cretaceous period, which was one of the warmest periods in Earth's history. And it was so warm that even Antarctica had forests instead of glaciers, and there were dinosaurs roaming around there. So in real life, we would not be able to find a frozen sauropod dinosaur, but scientists have found other cool prehistoric creatures preserved in ice, such as the woolly mammoth. I don't know if you guys heard about this in Siberia in 2012. And scientists have also found other creatures like bison and woolly rhinoceros. But these frozen fossils do not date to be older than the last ice age, which we learned in trivia when that was 20,000 years ago.
Okay, let's see. All right, so now we're jumping to the end of the Cretaceous period, so around 80 million years ago. And we have two Pokemon based on the T-Rex, or the theropod dinosaurs. So they are Tyrunt and Tyrantrum. And if we look at the Pokédex entry for the larger evolved form, Tyrantrum, it has two cool facts. So the first is that it says complete restoration is impossible, allowing room for theories that its entire body was once covered in a feather-like coat. And then it also says that thanks to its gargantuan jaws, which could shred thick metal plates as if they were paper, it was invincible in the ancient world it once inhabited.
So in real life, Tyrannosaurus, or as we all know it to be T-Rex, was a carnivorous theropod dinosaur that lived at the end of the Cretaceous period, around 90 to 66 million years ago. Dinosaurs are commonly portrayed as having scales, like other reptiles, but now scientists actually believe that some dinosaurs had feathers. Can you imagine a fuzzy T-Rex? Maybe not so scary, but still has razor-sharp teeth, so probably still scary. But anyway, T-Rex is known to have comically small arms compared to the rest of its body. And so as a juvenile, T-Rex's arms were actually more proportional to its size, but as it grew bigger, its arms remained the same size. So scientists still don't really know the reason for this. But in contrast to the tiny arms, the T-Rex did have huge jaws with the bite force of 8,000 pounds. And because its jaws were so powerful, it is possible that maybe T-Rex, he didn't really need to use its arms. I mean, if I had a bite force of 8,000 pounds, who cares about using arms to eat, right? Your jaws are so strong. So while it's pretty high up in the food chain, the natural predators of T-Rex included other T-Rex and a species of Spinosaurus.
Spinosaurus is always my favorite. Anyway, moving on. So now we have two sets of Pokemon left. So we're still in the end of the Cretaceous period. about 80 million years ago. So just a little bit before the mass extinction event. And we have two turtle Pokemon named Turtuoga and Caracosta, and they're based on the fossil turtle called the Archelon. And so if we read their Pokédex entries, it says that Turtuoga lived in the sea, but came up onto land to search for prey. And then for the evolved form, Caracosta, which is the bigger one here, it says that its jaws are terrifyingly powerful. It could eat Omastar and Omanyte whole and not be bothered in the slightest by their shells. So if you remember from the beginning of the presentation, Omanyte and Omastar are the Ammonite Pokemon. So apparently the turtle Pokemon eats the Ammonite Pokemon.
That is slightly terrifying, but super cool. And so in real life, Archelon was an extinct turtle that lived during the late Cretaceous, around 75 to 66 million years ago. It is the largest turtle to ever be documented, with a staggering length from the head to the tail of 15 feet and a width from one flipper to the other flipper of 13 feet. It could live up to 100 years old, and it lived near the surface of the ocean. They were omnivores and mostly probably ate soft-bodied organisms like jellyfish and other cephalopods. However, they did have powerful beaks, which could break open hard ammonite shells like the Pokemon Omanyte. And unlike the Pokemon, Archelon only came onto land to lay their eggs, and once those eggs were hatched, the newborn turtles would venture out into the ocean.
Okay, so now we're going to our last Pokemon for the night, and we've jumped all the way in time to the Cenozoic Era, which is the age of the mammals. And we are somewhere between the Pliocene and the Pleistocene epochs, which was somewhere around 5 million years ago. And we have a Pokemon named Mamoswine, who is pretty closely modeled after woolly mammoths. And so if we read his Pokédex entry, it says that Mamoswine flourished worldwide during the Ice Age, but its population declined when the masses of ice began to dwindle. And then there was another really cool fact in the Pokédex that I found that says that this Pokemon can be spotted in wall paintings from as far back as 10,000 years ago. So presumably ancient Poke people were drawing ancient Pokemon in their caves.
That is really cool, and I do have a comment about that after I tell you about mammoths in real life. So mammoths are an extinct group of elephants that lived during the Pliocene epoch about 5 million years ago to 4,000 years ago through the last ice age. They appeared millions of years after the mass extinction of dinosaurs. So no, dinosaurs and mammoths did not live together during the same time. I know if you've seen the Ice Age movies, which I really love to, they show that, and it's not true. But their distribution was widespread throughout the continents, and the environment at that time was like a tundra. And so global sea levels were actually 400 feet lower than they are today, and about 25% of the Earth's land masses were covered in ice. So the Pokédex mentions that Mamoswine was seen in cave paintings, right? And so that was dating back 10,000 years. And so, like I said, this is really interesting because cave paintings in real life, drawn by real humans living during the Ice Age, were discovered, and I hope I say this right, in the Ruffignac cave in France. And so the exact cause of the extinction of mammoths is still debated, but it could have been due to melting glaciers, which seems like similar to Mamoswine, and because of rising sea levels. Or it could have been by overhunting of humans about 3,700 years ago.
Okay, so that was our last Pokemon of the night. So we can take any questions that you guys have about either the real Pokemon, the fake Pokemon, or the real life animals. So if you're watching from WebEx, you can put those questions in the chat. And if you're watching from Facebook, you can comment on the live stream, and we'll try to answer some of them now. So,
I grew up watching Pokemon too, so I wouldn't blame you for calling them real. It felt like it was real, right? Like you grew up with them, so.
So let's see what's going on here. Okay. So I have one question here from Philip, who wants to know, would a horseshoe crab starve to death if flipped over, or just wait to be eaten by a predator? Probably both, I would think. What do you think, Ria? I think
you know more about paleontology than I do, so I would agree.
From my experience at the beach, if it's not going to get flipped over by a wave, it probably would just eventually die, or if it would either just die or would be eaten first. Whichever happens first is not good for it. So they try to use their tails to flip over, but it doesn't often work that well from what I have seen.
Sorry, horseshoe crab.
So let me see. Another question is, were Amargasaurus's neck spines there to deter predators from biting into it? Ria, do you remember what you read about Amargasaurus?
I mean, it probably was a defense mechanism, right? So dinosaurs, like, they, evolved to have, like Ankylosaurus, like the armored dinosaurs, right? They use their spikes to fight off predators. So I would say probably yes, that Amargasaurus, had those spikes on the necks. Again, I feel like I've also seen in like pictures that T-Rex is biting the neck of a Brachiosaurus or something. Looks awfully painful, so it would not be a bad idea to have spikes on the neck.
Yeah, I think we're not also exactly sure what they were used for. So some people have thought that there was like a, can't think of the word, like skin in between the spines to make it kind of sail-like, but I don't know how widely accepted that is now. We have another bite force of the Archelon, which I am trying to find now because I have absolutely no idea. I imagine it was pretty strong because, Ria, do you remember they could eat ammonites, right?
Yes, their jaws were strong enough to actually break open the shells of ammonites.
So I don't see a number, but it sounds like they were pretty strong. Not going to be as strong as a T-Rex at 8,000 pounds, but they're probably pretty strong. Let's see, another one's coming in now. They did. Question from Micah: did the megalodon live at the same time as dinosaurs 2.6 million years ago? And the bite force of it is 2,000 to 4,000 pounds, 60 feet long. So megalodons lived more recently than dinosaurs, as far as I know. Let me just check this. Ria, do you remember exactly when? So this says 23 million years ago. So they definitely lived way after the dinosaurs. So they did not overlap at all in time. But yes, they did have a very strong bite force. I think this is probably right, 2,000 to 4,000 pounds. Yeah, so he's one of my favorites. They should make they have a shark Pokemon, but it's not a megalodon. So they should make one of those next.
They really should. They should. And I always think about how like coelacanths they thought were extinct. They thought giant squid were extinct for a really long time, but they found. So I wonder about megalodon. I don't know if people would be thrilled about a giant, megalodon, but
I'm torn. I kind of want them to still be alive, but I'm also kind of terrified. So yeah, I don't know how I feel about that. Oh boy, my mom is watching. How old is Amora? So Amora was the sauropod dinosaur. So that was that 125 million years ago? So that one was pretty old. Let's see. Did mammoths have any predators? I think people, right, would have been predators. And maybe if one was old and or sick, another carnivorous animal, I don't know exactly, maybe saber-toothed cats. Yeah, so that's my guess. So Philip wants to know about the reason for feathers on a dinosaur. Do we know much about why? I mean, that's all sort of guesswork because we can never really know. But I think at least they think like young dinosaurs, young theropods would have had feathers, and that would have helped them stay warm. But I don't think scientists really know for sure yet. Here's Anthony asking a question. Which would have evolved as Pikachu, Squirtle, or Charmander? Well, Pikachu evolves with the Thunderstone, so it can evolve kind of whenever. I think Charmander might evolve at like level 14, something like that. So yeah, that's a silly question. Azzy wants to know, what does the word dinosaur originate from? Ria, you know this one, right?
Oh yeah, I believe it was who coined the term dinosaur. Am I correct with that?
Richard Owen, I think.
Was it? Yeah.
Yeah, I think it was, it meant terrible. I think
Tyrant lizard.
Yeah, like that. This is a hard one. What was the last dinosaur to be on Earth before the mass extinction? So I don't think we'll ever know exactly the last one, but T-Rex was kind of up there at the end. What other ones were at the very end? I think Triceratops might have been near the end. It's been a while since I've looked at dinosaurs. Right? This is definitely
That is correct. That is correct.
Yes, thank you. All right, let me see.
Oh, and adding to a thing about feathers, they were also used for thermal insulation. So rather than like flight, right? Because dinosaurs, they did not fly. And they did not live in the water.
Yes, but when birds evolved from dinosaurs, then they eventually could fly. But we think that took a little while. I have a question here from Wyatt, who wants to know, how many spikes does the Pokemon that looks like Brachiosaurus have? So the real one, it looks like it has a lot. I'm trying to count, but there's probably like 50. Let me see if it says here. These are hard questions. Let's see. It doesn't give an exact number, but I would definitely say it's over 50 spines, and they go all the way from like the back of the neck all the way down to the end of the tail. So that's a really strange dinosaur. He was always one of my favorites too. Let me see. What else do we have? We have a question about how much does the T-Rex eat? And I don't know if we'll ever really know the answer to that because, you know, they're not around anymore. But I would imagine it's quite a bit. They could probably polish off a decent-sized dinosaur if they're hungry. I imagine like other predators, they may not catch prey like every day, so they might, you know, gorge themselves when they do catch something. So they probably could eat like a pretty big dinosaur. Ria, do you know any more about this?
The best guess is about 40,000 calories per day. So that's a lot.
That is a lot. Here's the question about megalodons again. How did they go extinct? That's a good question. I don't know that. Probably, I would guess it's something with changing climate. Let's see. Extinct. Extinction. Okay, so it says climate change. So, blah, blah, blah. So it got colder, and the poles got the North and South Pole froze over, and it affected the coastal habitats where they. That's why we think they went extinct. So as usual, it's changing climate that kills off our species. Let's see, are there any starvation? Is there a consensus among paleontologists as to whether T-Rex was a predator or a scavenger? There's probably not a consensus because everyone has different ideas. I haven't heard recently. But yeah, that's a great question. I am not sure about that one.
Yeah, so they're not exactly sure, but there's evidence that they were scavengers as well as predators. So yeah, they don't really have the exact answer. So something people are still researching today.
My guess would be that it could have been a combination. So it was probably opportunistic. I don't think it would it might not ignore dead available prey, but probably also hunt. But I guess we'll have to wait for the scientists to really figure it out. Okay, so here's a question about, I don't know how to say this, but the Gaspar fossil Pokemon. So these are the newer ones that I'm not too familiar with. And from my experience, all I know is that you get different parts of the fossil, and then you can combine them how you want and make different animals. So I didn't know too much about them, so I didn't put them in the presentation. But yes, I have heard of them, and they are pretty cool. I think there's one that looks kind of like a prehistoric fish, which I thought was cool. Yeah, so next time we'll have to include those guys. Let's see. All right, and maybe one more question. Yes, Deanna, there will be a recording of this, and we'll post it somewhere on our website soon. But that wasn't the question we're going to end on. Let's see.
I do have a question for you, Julie.
God, okay.
What is your favorite Pokemon?
Okay, this is a good question. I've been trying to think of an answer for this one. I would say probably Pikachu because I'm stereotypical. My phone is a Pikachu. But I also really like Bulbasaur. And for fossil Pokemon, Kabutops was always my favorite. Does Ria have a favorite Pokemon?
I'm also stereotypical, and I really like Pikachu. I also like Bulbasaur because it always reminded me of garlic. And then I also did always like Charizard.
Yes, Charizard is also his favorite. He was cool. He's kind of like a dinosaur, but dragon. Okay, so we are at 7:30 now, so we're going to cut it off here. Thank you, everyone who participated tonight and listened to us talk about Pokemon and Geologic Time. Our next late night will be, November? So December, the first Wednesday in December. I think it's the 2nd. And we'll be having a guest speaker talk about bizarre beasts. If you liked tonight or didn't like tonight, please fill out the survey. We just put a link to it in the chat box. Let us know what you thought, how we can make it better, or what you liked. So yeah, thank you everyone for tuning in. Does Ria have something to say?
Actually, also, if you want to or are interested in hearing about the geology of Iceland, we do have our Ask a Geologist. Our series is this Friday at 1 p.m. So tune in. The information should be on our social media as well as our website. So again, if you want to know about the geology of Iceland, you can hear a talk by Dr. Tini Giovanelli, and that's again on Friday at 1 p.m. until 2.
All right. Thank you, everyone. Have a good night.